In this video, we're going to talk about some different ways of accessing our network devices. Hi, my name is Kevin Wallace, and this video is a sample from our CCST Networking series. And the first thing we're going to do in this video is take a look at some legacy ways of connecting into a network device. We'll consider things like mainframe and mini computer connections from back in the day. Then we'll talk about some remote terminal protocols. If we're using a terminal emulator, maybe we'll use Telnet, or hopefully we'll use Secure Shell because that's secure. We'll talk about snmp. And we'll consider Cisco's DNA Center and the remote desktop protocol over a VPN to give us a remote connection. And we'll also take a look at the Meraki Cloud-Managed Network. And this topic does come from Cisco's brand new CCST Networking certification. And I actually have an entire course covering every topic in CCST Networking. And I want to give you a couple of options of accessing that course. It's available on Udemy, and currently on Udemy it's got a 4.8 star rating, and it's a bestseller, or this is one course that you can get as part of our All Access Pass. That's where you get access to all the courses currently in our on-demand library. You see the listing here. We've got all sorts of Cisco courses and CompTIA, cloud, cybersecurity. If you were to buy these courses individually, that would cost over $7,500. But you can get access to these for just $29 a month as part of our All Access Pass. So those are your two different options for getting your hands on the CCST Networking video training series. You can pay less than $20 one time and have it forever at Udemy, or if you want access to our entire library of content, including CCST Networking, for $29 a month, you might want to check out our All Access Pass, and I've given you the links on screen and also in the description where you can learn more. Now let's check out a few different options for accessing our network devices. In this video, we're going to take a look at some different options for accessing our network devices. And to begin with, let's go way back in time to the mainframes and mini computers. Back in those days, instead of having a PC at our disposal, we had what were frequently called dumb terminals. They didn't really have any intelligence built within them. They could just act as an interface to this mainframe or to this mini computer, and they might have connected via a serial cable. Then, as technology progressed, we started to have PCs that could do other things. They could run word processing, and they could run terminal emulation software. So these PCs could replace the role of the terminal, and they could connect to our mainframes and our mini computers via this serial cable using a serial port on the back of the PC. And when Cisco started coming out with its networking gear, such as routers and switches, they provided console ports where that serial cable could go into a router. And today, we still have access to those console ports. Here we see a Cisco 4300 series router, and I've got my MacBook Air plugged into the console cable coming out of a USB port, because today's computers don't typically have serial ports on them. I'm going through a USB to serial adapter, and I'm going into that console port. Or I've also got a cable where I could plug directly into a USB type mini B port. But in this example, I'm going into that console port using a console cable. And I have to have an application running on my laptop that makes it act like a terminal. And what I happen to be using on my Mac is Serial. If you're using Microsoft Windows, you might want to take a look at PuTTY for Microsoft Windows. And by the way, that's not a typo. It's uppercase P, lowercase u, and then uppercase TTY, because these connections were typically called TTY connections. However, we don't always have the luxury of being in close proximity with the device we're administering. We might want to connect remotely across the network, and we could do that using an application such as Telnet. With Telnet, we could open up a console on our computer and say Telnet and give the destination address. The downside of Telnet, though, is it's not secure, and it's not recommended, because if somebody were to capture those packets going through the network, they would be able to see what you're typing in, including any password credentials you entered. A better alternative to Telnet is Secure Shell, or SSH for short. With Secure Shell, not only is the user authenticated to get into the device, the transfer of data is encrypted. And this is a way that we could get to the CLI, the command line interface, to some of our network devices. However, we're getting to these devices one at a time. If we have a fairly large network and we want to monitor dozens or hundreds of devices, we might turn to something like an snmp server. SNMP, that stands for Simple Network Management Protocol, and an SNMP server is a type of NMS, a network management system. And SNMP is a prime example of an NMS, and what SNMP can do is have one machine like this server act as an SNMP manager, and then we can install SNMP agents on different devices that we want to monitor, be they routers or switches or firewalls or other servers. And SNMP allows the manager to query the agents to ask for information. We might say, for example, show me the bandwidth utilization on a particular interface. But in addition to that, the SNMP agent can initiate the conversation. We can pre-configure those SNMP agents with a set of SNMP traps. These are things that they look for. Maybe if the temperature in a room goes above a certain threshold, that can generate an alert. That's called an SNMP trap. And the SNMP agents can proactively let the SNMP manager know that this threshold has been reached. And Cisco's flagship product for enterprise network management today is Cisco DNA Center. With DNA Center, not only do we have a graphical interface we can use to manage our network devices, we can also write scripts. For example, we might write a script in the Python programming language, and as we execute that script, it can send instructions to Cisco DNA Center. These instructions are sometimes called REST APIs. REST stands for Representational State Transfer, and API, that's Application Programming Interface. And what a REST API is essentially a command that uses HTTP verbs. When you go to a website and you get information from that website, you're using the GET HTTP verb. If you send information to that website, you might be using the POST verb. Well, we're going to be using those REST APIs to send and request information to and from Cisco DNA Center. And Cisco DNA Center can reach out to our different network devices, and using whatever language those network devices speak, Cisco DNA Center can send instructions down to those devices using southbound APIs. Next, let's consider a situation where we have multiple offices, and we want to interconnect these offices securely so I can be at one office, maybe the headquarters, and manage a device at the other office, maybe branch office 1. Well, a way we could do that through an untrusted network like the internet is to construct a VPN tunnel. A VPN, that stands for Virtual Private Network, and it allows us to use what is typically a non-secure internet connection securely. We can set up this virtual tunnel which can encrypt all of our traffic flowing between these two sites. So if some bad actor were to intercept those packets, they wouldn't be able to make sense of them because they're all scrambled up. And we've considered a few ways that we could get access to the command line interface on a device through Telnet or Secure Shell or a console port, but sometimes I might want access to a server's screen, a GUI interface. Let's say that I'm at my laptop at the headquarters and I want to get to this Microsoft Windows device over at the branch office. How can I do that and see the graphical interface of Microsoft Windows? Well, through the protection of that VPN, I can use a protocol called RDP, the Remote Desktop Protocol, and that's going to allow me, as the name suggests, to remotely access the desktop on that other device. And if we're managing a network with multiple locations, maybe around the world, a growing trend is to use cloud-based management. Let's say that we've got all these different offices, and they're all part of a Cisco Meraki Cloud-Managed Network. They can all report information back to the cloud. And then we can be on our terminal anywhere in the world and fire up this console, and we can access information about devices at any of our offices. In fact, we can integrate other add-ons to this Meraki interface. Cisco calls this FSO, Full Stack Observability, where we have one platform to access information about all things networking in all of our locations. So let's sum up what we've talked about in this video regarding different ways that we might access our network devices. We began by talking about how we could use a terminal emulator to connect to the console port of a router or switch. We could also use Telnet. It's much preferred, though, if we use SSH, Secure Shell, because that's authenticated and encrypted. Telnet's not. We could monitor and manage multiple devices with an NMS, a network management system, such as an SNMP manager. However, Cisco's recommendation today would be to use something like a Python script talking to Cisco DNA Center. And if we want to securely interconnect geographically dispersed offices, We can do that through an untrusted internet connection using a VPN, where we can build an encrypted tunnel through the internet. And we said that we weren't limited to the command line interface when we're managing a device. We could actually get the desktop of another machine remotely using RDP, the Remote Desktop Protocol. And finally, we took a look at Cisco's Meraki Cloud-Managed Network, where we could have devices around the world all reporting information to the cloud, and we could access that cloud-based interface from basically anywhere and have observability into our entire network.